Hi everyone, welcome back to my YouTube channel Solve and Answer. In today's video, I will be doing real numbers, chapter 1, standard 10, Euclid division lemma, Euclid division algorithm, and few sums of exercise 1.1. So let us start. Euclid division lemma. So Euclid was a Greek mathematician who discovered this lemma. Lemma is a statement of proof which is used to prove another statement. According to Euclid division lemma, if we have two positive integers क्या है? Positive numbers a and b, then there exists unique integers q and r which satisfies the condition a is equals to bq plus r, where r is equal to or more than 0 but less than b. तो यहाँ पे आपको दो numbers divide करने होंगे and suppose the numbers are 29 and 3, you want to divide them. The greater number you will consider it to be a and the smaller one b. Let us divide them. So here this 3 is the divisor, this is the dividend, this is the quotient and this is the remainder. तो जब आप suppose you don't know the dividend, okay, you don't know the dividend and you have been given the divisor, you know the quotient and you know the remainder. How will you find out? You can use this method to find out the dividend. A is equals to bq plus r. For example, yes, you see this sum over here. So you don't know, suppose you don't know what is the dividend here. How will you find it out? You know the divisor 3 and you multiply it with the quotient and then add the remainder. You will get the answer. Okay. So this is the way you can find out the dividend. So basically this is the meaning of the statement here. Now the next one, you see there is a relation between r and b. What is r? R is the remainder and b is the divisor. Okay. So suppose, and what it is saying that the remainder is always more than 0, okay, and it can be 0 also but less than b. So suppose I am having a divisor 4. So the रिमाइंडर्स कौन से रिमाइंडर्स मेरे पास हो सकते हैं? 0, 1, 2, 3. I cannot get a remainder 4 here because if I write 4 here, I can continue the division. 4 ones are 4 and then I'll get a 0. So this is the meaning of the statement here. Suppose I am having a divisor 5. So what are the remainders I can expect here is 0, 1, 2, 3, 4. Okay. Hope you have understood division lemma. Now moving on. Coming to Euclid's division algorithm, algorithm is nothing but the steps that are involved in a process. For example, if you are making a cup of tea, so the steps that are involved in making a cup of tea is called nothing but algorithm. So this name itself seems to be very complicated, but when you see the steps and the process, you will feel that it is so easy, just a piece of cake. So basically here you are going to divide two numbers. So suppose I am having two numbers over here, 42 and 455. We are going to divide them and the purpose of dividing is to find out the HCF. Okay, you have already studied finding out HCF in your lower classes, but by doing finding out in this method, you will be able to find out the HCF of bigger number in a very easier way. So the bigger number you will take, you will consider it to be a dividend and the smaller is the divisor. Then you continue dividing. So now you got a remainder 35. So this division should be continued until you get the remainder 0. So now I did not get a remainder 0. I will write this division in the form of Euclid's division lemma. So what was that? A is equals to bq plus r. So here A is what? 455 and that is 42 into 10 plus 35, and here the remainder is not equal to 0. Continue dividing further. Again this 35 is the divisor and 42 the divisor earlier becomes the dividend now. 35 ones are 35 and I get a remainder 7 here, which is not equal to 0 again. So this step I will write it in the form of lemma. So here the remainder is 7, which is not equal to 0. Continue dividing further. This 35 becomes the dividend, and now I get a remainder 0. So I will write it, 35 is 7 into 5 plus 0, and the remainder what I got is 0. Okay. So basically when the remainder is 0, the divisor of that step is the HCF. So now you came to know how to find out the HCF, okay, by dividing. You have to go on dividing till you get the number remainder 0, and the divisor, okay, when you get the remainder 0 is the HCF. So this is Euclid's division algorithm. So moving on. So let us see the question number 2 of exercise 1.1. Show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. So when you look at this form 6 cube plus 1, you will at once remember that this is of the form a is equals to b cube plus r, which we already did. ये उससे resemblance है इसका, a is equals to b cube plus r. Okay. So here what is b? The value of b is 6, and the remainder here, okay, they are the 3 remainders given, and we have to prove that they are odd positive integer. We have to show that they are odd positive integers. So for that, what you are going to do is start with this a first. So let a be any positive integer, and what is b then? B is 6. So according to Euclid's division algorithm, a is 6q plus r. So if the divisor is 6, so how many remainders you can think of? So here the value of q here is greater or equal to 0, okay, this is greater or equal to 0, and r, the divisor is 6, so the remainder here you will think of is 0, 1, 2, 3, 4 and 5, okay, and here the value of r is greater or equal to 0 but less than this 6. This I had already done in the previous clip, okay, of this video. You can just check it out. So now the remaining thing has to be done in separately in a rough work column. So if r is 0, okay, what answer I will get? A is equals to 6q. If r is 1, okay, then a will be 6q plus 1. If r is 2, a will be 6q plus 2. If r is 3, a will be 6q plus 3. If r is 4, a will be 6q plus 4. If r is 5, a will be 6q plus 5. So now you see you are getting somewhat similar answers that have been given over here. So this 6q, this 6 is even, so this number becomes even, this one becomes even. 6q plus 1, this adding even to an odd will give you odd. Again here you have 6q, this 6 plus 2 is even, even integer, 6 plus 3 is odd, okay, this is even, and you are adding an even to odd will give you odd. Again 6 plus 4, 2 even number will give you even only, and this 6q plus 5, this is even adding to an odd integer will give you odd. So here you see you are having 6q, 6q plus 2 and 6q plus 4, they are even integers. So if a is 6q or 6q plus 2 or 6q plus 4, okay, they are even, okay, even numbers divisible by 2, okay, all even numbers are divisible by 2. But what about this odd numbers? So, here 6q plus 1, 6q plus 3 and 6q plus 5 are positive. Yes, they are positive only because you have plus 1, plus 3 and plus 5, positive odd integers. So, this thing you had to show and it has been showed over here. So, this part you can do it in a rougher column, and this is the main answer which you have to do in your answer sheet. So, coming to the next question. So, question number 3, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number? Maximum means the highest common factor. Maximum means the highest common factor you have to find out. Maximum number of columns in which they can march. For this you are given two numbers and you will be finding out the highest common factor, and that highest common factor will give you the number of columns in which they can march. So, here you will start by writing number of contingent members is how much? 616, and number of army band members is 32. So, now you calculate the HCF of 616 and 32, and that will give you the number of columns in which they can march. So, 616 is greater than 32, you divide it in a rough work column, okay, and you will go on dividing till you get 0. So, here you did not get a 0. So, this step has to be written here. 616 is equals to 32 into 19 plus 8, and again here the remainder is not equal to 0. Then 8 4s are 32. Now, you get a remainder 0. So, this step has to be written here. 32 is 8 into 4 plus 0. So, therefore, the highest common factor, the HCF of 616 and 32 is 8. Okay. So, the maximum number of column in which they can march is 8. Okay. So, this was the way you do this sum. Hope you have understood the way I have taught in this video. Thanks for watching my video. Do share it among your friends and please subscribe to my channel.